right, welcome everybody. I'm Luciano Fogoros. I'm the co-founder of IoT World, and I want to thank you for supporting IoT World Days. Today we have an exciting panelist session around industrial cybersecurity that will be moderated by Joe Wise. And Joe, the floor is yours. Thank you for supporting IoT World over the last few years.
Lucian, thank you. And I wanted to welcome and thank everybody for joining us. I think to most people, it's probably late this afternoon. And I also wanted to thank the sponsors for this session, which are Trend Micro and Tempered Networks. Before we begin, I also wanted to encourage questions. I was told, please use the Q&A tool, not the chat box. And we will try as best as we can to answer the questions in real time. And Lucian has told me if we don't, somehow we will manage to get back to you with that. We have a very interesting panel as they represent multiple facets of the IoT control system security community. This includes threat, OT, IT, and training. Given recent developments that have resulted in a presidential executive order, I did want to mention, this is on the bulk electric systems, I did want to mention that there are actually two aspects to control system cybersecurity. Network issues that most of the attendees are familiar with, and this session will be primarily addressing. And the second, which is more of an insidious type, are hardware issues that cannot be found just from network monitoring, which is beyond the scope of this panel. And I'm going to be addressing those issues July 15th in a presentation to Purdue University in their summer cybersecurity seminar. Industrial and manufacturing organizations have been connecting systems for more than 20 years. The concept of Industry 4.0, in a sense, is not new. Unfortunately, engineers are not good marketers. And we weren't able to come up with the buzzword that's out there now of Industry 4.0, kind of the same thing that happened with Smart Grid and some of the others. From a cybersecurity perspective, what is Industry 4.0 and what makes it different? From a cybersecurity perspective, I believe Industry 4.0 is lots of sensors in big data analytics. And that's obviously a very broad statement and doesn't directly include the myriad needs, and that include things like secure interoperable protocols, secure gateways, secure sensors and sensing networks, secure remote access, secure coding, etc. There is an entire laundry list of everything that needs to be there, as well as the people or the training. And as I mentioned, we've got a diverse panel to discuss the various aspects of Industry 4.0. And that'll include threats, control system issues, training, and application of IT concepts to OT. I have provided questions to each of the panelists that are in their area of expertise. And what I'm going to be doing is giving those questions in 5 minutes to each of the panelists to start with, and then have the other panelists chime in. And that's also where I'm going to ask the audience, if you have questions, please, come in. So the first question I've got is going to Chuck Brooks from the Cybersecurity Collaborative. What are the new cyber threats that are being introduced by Industry 4.0? Chuck, the floor is yours. Wait a minute. Chuck, you need to unmute yourself.
Okay. Now, as you mentioned, Industry 4.0 is all sensors. It's a new interconnectivity, and it deals with a lot of other issues, including automation and machine learning, artificial intelligence, and of course, predictive analytics. And with those come threats. For one thing, now with the capabilities of machine learning, adversaries can be much more sophisticated in spear phishing attempts. to get at operating systems and actually IIoT systems too. So the threats have been magnified. There's been a quick history in the last 5 years. It probably started before that, but it started with Stuxnet, which was done with a thumb drive, but then it quickly moved to Havex and Shellmill, Black Energy, Indestroyer, and most recently Triton, which is a sophisticated malware that's done mostly through spear phishing attacks. So what has happened is a lot of these adversaries, which now include state operators, have been able to use some of these new technologies, machine learning, to hide algorithms, to discover algorithms, and to penetrate systems looking for ports and vulnerabilities. So it's made the situation much more dangerous. The other thing is that because the operating systems used mostly in the industrial side are not as new, is not used in the IT side, a lot of them not been updated. So you're dealing with manufacturers and hardware that basically doesn't have a lot of the protections that the new types of softwares have in other systems. So it makes for ripe targets. And then I think the third aspect to this is it's now being used obviously for adversarial purposes, where you can take out a power plant or electric system or water system, which has happened recently in global politics, but it also can be used now for ransomware. If you could take down a state and local power plant, you could ask for money, convert it into cryptocurrency. So a lot of these new threats arise with the connectivity, and it's just part of the world we're in now, which has been pushed forward more with the digital aspects of it now that we're all working at home. But it's really Industry 4.0 is more vulnerability, more attack space, and more threat actors.
Okay, Chuck, thank you. I guess as moderator, I get a chance to say something first, and then I want to hand it over to the rest of the panel to see what else they have to say. To me, this is just an observation, listening to what Chuck just said. In a funny sense, what COVID has done is pushed us all into Industry 4.0, because what it's done is it's pushed us all, or at least many of us, to having to do remote access. And, that's been kind of one of the key aspects of Industry 4.0.
Yeah, Joe, I just wanted to add one thing, which is we are talking about the new threats, and yet we are not really even prepared to handle the old threats. So this is just added complexity. And so just because we have a new situation, new environment, the old threats are still there. So we still need to be cognizant of that. So just one fact I wanted to mention, which is in 2011, Pentagon had declared internet as a war domain, okay? And the statement they made was our reliance on cyberspace, and I'm reading this from there directly, stands in stark contrast to the inadequacy of our cybersecurity preparedness. So I think we just wanted to kind of mention that as we set the context for the discussion, that we are talking about 4.0 and the added complexity and the connectivity and the more sensors, but we still have the legacy dinosaurs, the Modbuses and the BACnets, so we are still in an interconnected state. So just wanted to mention that. Thank you.
Thank you.
Good points, and I wholly agree. And I think if you add on the new cloud computing aspects to it, plus the new supply chain complexity, it basically proves your point. We're mixing cyber physical systems, some of them very old, like legacy systems, like you just mentioned, with the new infrastructure that is not prepared to bring up those legacy systems and creates a lot of gaps and vulnerabilities.
Yeah, I would also add to that that some of the old threats, as Pamela mentioned, obviously are there and vulnerabilities, but that ubiquitous remote connectivity that Joe was talking about is just making them way more exposed, right? It's like a year ago there was that whole thing in the news of some teenagers figuring out how to use just amateur radio to turn on storm alarms in cities in Texas, right? Because basically you just had to know the radio frequency. but they could only do that locally because it's obviously just a local system. Now that all systems are getting equipped with remote connectivity and remote management, it's much easier to exploit such vulnerabilities. And unfortunately, the mentality of people designing those systems and maintaining those systems doesn't necessarily catch up with those changes, right? That they can still assume that if they have access and know how to do things, then it's okay. And sort of that kind of security by obscurity or security by network access is still kind of primary defense line in many people's minds.
Brian, do you have any thoughts? Putting you on the spot.
Well, I think that segues in a little bit into the next question. But before you ask it, I'm thinking about consumer stuff that's on the internet, like smart doorbells being used way beyond what the doorbell manufacturer may have intended to keep people in certain countries and certain regions, maybe keep track of them, make sure that they're in their house when somebody else wants them to be. I mean, you know, the people making, to follow on what Dimitri just said, the folks making all of these smart gadgets and items are thinking about increasing our lifestyle, you know, enhancing our lifestyle in some way, but inadvertently, maybe not thinking and even unaware about another threat vector because everything is so connected, and somebody's maybe in Texas, as somebody mentioned, and it might not be in Texas, it might be somewhere else, has a bright idea to go to showdown.
Yeah. I've got one other point that was a follow-up, and then want to make sure it's open to the audience. I don't know, Lucian, if we've got any questions so far, but I wanted to follow up to the point where, and this is something that had come up in one of our ISA special working groups, the issue of the interoperability of the old technology with the new technology. And one of the concerns was, if the older technology just simply didn't have enough security in it, you're going to end up with, if you will, the lowest common denominator. So even though you had more security in the new technology, that older technology was going to preclude the newer one from being able to really be used.
Well, I agree on that. I mean, you may open up new vulnerabilities too with the new technology placed on the old technology that will allow the old technology to get compromised. So you really have to look at a vulnerability analysis up front before you put systems on top of each other. And that's been a problem on cost, but mostly is someone earlier mentioned on training. There's just not enough people that are trained and understand OT systems as there is an IT system. So there's a big gap here.
Okay. Any other thoughts before we move on to the next? Lucian, anything you want to add?
Question in the Q&A, so go ahead, and if you'd like to move to the next one, or I think somebody else wanted to add.
Yeah, I just wanted to add very quickly to what Joe was saying about interoperability, that the problem with interoperability and sort of lowering the security standards because of that, the problem that I see happening a lot is systems that were originally designed to be internal systems, some sort of a backend systems that were only meant to talk to other internal systems. They were designed with that assumption. And so they trust that no external attacker can ever access them. And they also trust all the inputs that they're getting when other systems are calling them and invoking them. And then due to re-architecturing of the overall systems, etc., they often either become publicly accessible, although they have never been designed to be publicly accessible, or become accessible kind of semi-publicly accessible through other sort of registered clients, etc., but they can no longer trust the inputs that they're getting from other systems, because those other systems can be compromised as well, or used as a proxy for a compromise. And that unfortunately happens a lot due to that interoperability issue and the overall re-architecture of the compound systems.
Okay, before I guess we move on to the next, there's been a couple of questions come in. And Lucian, don't do this to me again. They're good questions, but they're hard questions. The first one was related to some certifications for Industry 4.0 and the implications to cybersecurity. I know from my efforts on, on ISA, the International Society of Automation, ISA 99, ISA Secure, et cetera. There are certifications going on for, control systems per se, or more control system boxes. I'm not personally aware of anything that's going on specific to Industry 4.0, with respect to certification for cybersecurity. Anybody on the panel aware?
So I'm aware of a lot of standards, but not a certification. No.
Okay.
Not at the moment.
I agree with Pamela. I mean, there's NIST standards, there's IEC 62443, and then there's also ISO 27001 standards, but not certifications, which is a big difference.
There's a big difference, and the question was really toward Industry 4.0.
Joe, just if I may interrupt there, I was at the ARC forum in Orlando in February, and one of the executives from a top controls company in the United States, in the world actually, she's mentioned, says, if I was a couple of decades younger, I would start a certifications entity. So that goes to tell you that there is a recognition even at the vendor side that there may be some gaps there.
Yeah. Lucian, you're going to help me with the time because we got, 3 more questions to go through with the panel. One of the next question was, what role should federal regulators play with regard to cybersecurity standards across distributed energy resources on the distribution grid? And that's obviously a regulatory and whatever question, because what's happening is the Energy Policy Act of 2005 prevented the federal regulators from, number one, writing standards, and they're only to address the bulk electric system. So it's an important question, but not anything I know what to answer here. Again, if there are any other thoughts, please bring them up.
I think that in general, we will see more and more regulation coming in the IoT space. Obviously, that there is already some legislation coming in some states in general, like California now has some IoT regulation. And they start with pretty basic things like no hard-coded credentials and things like that. But I think as more and more IoT enters our lives, both on the sort of state utility level and personal consumer level, there will be more and more pressure to start regulating that industry. After all, we do have our code for civil engineering and now for the bridges and roads and that all sort of is natural to us. And I think since IoT is now starting to touch our lives in a very meaningful way and touching our physical security, I think we'll see more and more regulation coming in that area as well.
In Europe, they just came out with for consumer-facing IoT products. They just came out with a standard. I believe it was ENISA, but I'll have to double check my notes on that. But so it is starting to happen. But I think coming back to the federal regulation in this country, my biggest fear is that if the regulation is not comprehensive and set up adequately, then it can do more harm than good. Because you will take that, you will think that if I'm compliant with this, I'm meeting my risks, and it's not going to be the case. So it really has to be well thought out and well created, and it has to be comprehensive. There are, I know, DoD, for instance, is coming out with cybersecurity standard, CMMC, for instance. I think those offer more promise than having a regulation, in my opinion. You know, to have a standard which is comprehensive, is far-reaching, and is well laid out, and that can be used for adhering to that and kind of achieving two things. One is security, as well as the assurance that it is baselineable. You know, you can create a baseline, you can repeat it, you can scale and standardize.
There's one, I think we'll do one last question and then move on to the next question, and we can always come back later because I'm worried about time. And this is a really, really interesting question that we've been fighting with for many, many years. It says, security has always been a game of cat and mouse, with the bad actors finding weaknesses and then security professionals closing those weaknesses. It means that security professionals are always on the defensive. How do we flip that script? How do we get the security professional ahead of the bad actors for a change? What operating methodologies can organizations use to move security to a proactive instead of reactive activity? Thoughts?
Can I just take a quick stab at that? You know, for me, that means, so when I started my company, it was to lay out cybersecurity strategy for companies, right? These days, just having a cybersecurity strategy is not enough, right? That it has to be agile, it has to be risk-driven, and it has to be constantly you know, changing with the times. So, for example, and I give this example in my, you know, when I get my 5 minutes, Joe, when we're talking about the risk landscape out there, right? Talking about the bad actors, we have to know who those bad actors are, because that does determine the equation, all right? Because there are some bad actors who can get to you no matter how good your security is going to be, okay? Those are the guys who with, or gals with really deep pockets, you know, the state actors of the world. When you're talking about vulnerabilities and insecurity vulnerabilities at a chip level, then you are really talking about the risk definition being changing right under our eyes, okay? Under our feet or eyes. So how do we deal with that? We have to kind of separate out, well, you know, take that risk-based approach and apply it real time, all the time, make it dynamic, which is know your organization, know your assets. That goes without saying, but we don't even have that yet. A lot of companies, organizations cannot even clearly define where their assets are. Without that asset inventory, you don't have a leg to stand on, okay? But there are some existing methodology that we can leverage, but a lot of it will have to be really dynamic to stay ahead of not necessarily the bad actors, but identifying our risks and feeling that competent that we have identified those, we are dealing with them, and that if something does break, we are not going to just roll over and play dead, right? If you get a compromise on a system or a organization, the whole organization shouldn't be able to be pulled down, right? It should be localized. That effect should be localized. I call this the ADECO prison methodology, where there's a prison in Colorado, maximum state security, where each cell, this is solitary confinement for each cellmate. These are the bombers, Unabomber of the world, you know, kind of those kind of terrorist folks who are housed there. Maximum security, but each cell, for instance, has, you can't talk to each other. Each cell has a window, but it faces the sky. So you cannot see what else is going on. Where you are, you can't determine your context. It's extremely localized, so that even if somebody wanted to define that we are at a particular location, they can't do so because they have no point of reference. So that's the kind of mentality we need to have. And that can come with security by design, by privacy by design. We need to have that as a part of a mindset. Right now, we're talking about security as an add-on. Game is already over, guys. If you're talking about add-on, it has to be at the very outset. And even if you're going to go down and go back and put it in place, it doesn't mean that you still can't do both. Meaning for the legacy system, legacy part of the organization, you create a kind of isolation paradigm. But for your new system, you're really looking at business process, business development, product development, product operation, everything to have security by design.
What I wanted to do is, this is really almost a lead in, Brian, to to the next question. And that is, what are the cybersecurity specific technical issues associated with Industry 4.0? Moreover, how does 100% trust system, which is, if you will, the IT, interface with a zero trust system, which is the control system environment? So, Brian, the floor is yours.
Thanks. You know, I just want to, I'm gonna lead into what you just asked me by going back to what Pamela was talking about a little bit, in terms of helping the security professional get ahead of the game, because the question is things are getting more complex, right? Industry 4.0, more things, more processes, more data, bleeding edge AI, no chance for a human to really intervene. And we're now outsourcing more critical functions that we used to do, you know, and then the stakes are going up. So how can we help the people get ahead of the game? One of the, in addition to everything Pamela was talking about, I would say use innovative tooling to get things back to Industry 3.0. And so let me talk about that a little bit. And that's kind of the answer to your question, Joe. How do things like control systems, where everything trusts each other, they were built originally for networks that were supposed to be separated into a private network on a LAN. How do we get data from those systems and interface that with the world of IT, get data into the cloud, into the data center, where there are resources to perform some of this really advanced big data analytics and feedback systems. So, and what I would say is use innovative technology to get things back into a logical air gap. So that's my summary. So how do you do that? So I could get into that, but before we do that, you asked me, what are the problems? What are the specific challenges about this? And I'm just going to mention a few of them have been mentioned already. You know, one is, you know, the consequences are going up. Availability and especially data integrity could be compromised, and the consequences of that can go up to where, instead of, say, we lose some money, you know, our business is not functioning, now we're talking about things breaking, or you know, control systems causing you know, malfunctioning, and maybe even intentionally causing damage or even harm to people. So the stakes are going higher. As been mentioned, these systems have been built over time and a long time ago out of equipment that was trusting everything. And often that equipment doesn't have the resources to be patched and to be taught how to defend itself in and when the threat landscape has changed and is more exposed. The best defense, as I'm saying, is to get back into an air gap. And we can't do that physically, but we can do it logically. Another point, a few of my other points have been already made here. I'm going to skip through that because we give you back some time. I think another thing that is key is that in networking, a lot of access control and security policies are mixed in with the communication policies, meaning we're using things like the IP address to identify things and to build security policies around networks and how we define networks. And then we define access control in those same terms. And we need to use innovative technologies and different protocols and systems that create namespaces, logical separations between identities of things and the locations of things, which could change. And also, we need to reduce the complexity of what the domain experts are having to handle. You know, it's hard enough for IT to take on the job of securing the OT network. And that's something that I know Joe and I have talked about a bit, but domain experts understand if their system is operating Domain experts might be in a better position to see if things have been compromised. But if they're having to outsource the job to IT or to, say, a learning system, which is building a baseline, how do they know the data that is building that baseline is good data to build the baseline with? And then there's some other challenges that haven't been mentioned here. One is that we have a last mile problem. There's a lot of fancy systems and ideas out there, but they don't really address the fact that these systems can't be patched and we can't get the data to the cloud in the first place or to the data center in the first place intact necessarily. In some cases, we're talking about wires. In some cases, the things that we're protecting in these systems are spread out so far that there are no wires. So we're talking about wireless technology, which opens things up even more. And then the last thing I'll say, and I'm going to shut up, is that to get to things on planet Earth, sometimes we need remote access even before we have a pandemic. And people, technicians, will get access to those things. Sometimes they'll put a patch cable in around a system. Sometimes in, a smart building, they'll put an access point behind the building management system so they can get at the equipment. And if they know they need to show up every month, they might leave their access point there. So.
Thanks. Any other question, or excuse me, any other comments from any of the other panelists?
Well, just to sort of reiterate, I think one of the most important things the panel brought up, of course, it really does come down to risk management holistically, and that's, and what Brian said, having visibility into your system. Without that, you can't really remedy situations. And there's some things that Brian just mentioned, including access control and encryption of data that can be used. But in the long run, it is a vulnerable system, and other half of the equation is resiliency. You have to assume that you're going to be at some point breached, and you have to have some sort of risk management program in place to be able to still operate or have a backup. And I think that's critical as we move into Industry 4.0. As we move into the integration of these newer technologies with old systems, this can happen more often.
Yeah, and again, in general, again, what both Pamela and Brian were talking about, going sort of from reactive to proactive, from reactive to secure design, from kind of trying to figure out some sort of attack patterns or relying on machine learning or artificial intelligence that would somehow magically, based on some sort of data that God knows whether it's valid or not, or contains attacks or doesn't contain attacks, would somehow magically detect and prevent attack. Going from that to actually proactive design, allow lists rather than deny lists, define what kind of behavior is expected, define what kind of access is expected, define what kind of connectivity between systems is expected, what kind of data is expected, and enforce that. So enforce the proper behavior, the proper inputs, proper outputs, rather than rely on some sort of pattern detection or add-ons or whatever.
Brian, I was asked to ask you again, can you just provide maybe a little bit more detail when you talked about the air gap? Because I think one of the things a lot of people think of is the air gap is this separation between systems, and therefore you can't get from one to the other.
Sure. So this conceptually, in terms of concepts that we already understand, imagine if you could put all of the components and pieces of a control system on a network where everything was in a specific VPN, specifically encrypted tunnels that are in a positive security model, meaning only this sensor can talk through this PLC up to this particular server. And that PLC can only receive commands from this other particular system or server. So if you know, and in the world of things, I mean, in critical infrastructure, we do actually know ahead of time. This is not like the public internet. This may not apply to certain cases B2C, but you know what you have and you know what should be allowed to communicate. And so it is a tough job to figure that out. But when you construct a positive security model and you carry all of that traffic inside of a zero trust orchestrated protocol with basically mandatory encryption, AES 256 encryption, and you can orchestrate it in terms of identities instead of IP addresses, and then give the control of those policies to the domain experts. That's critical. Instead of handing it over to somebody who's an expert in networking, hand it over to somebody who's an expert in the things that are talking.
Yeah, and just to add, Stuxnet was air-gapped, and that that attack happened on an air-gapped network, right? So remember, I was talking about if there are state actors who are driven by a particular motive, somebody who has the right motivation, right resources can get through even then. So I think, Brian, what you said is going to be very important in dealing with that scenario. But remember that Adecco prison I was talking about, that's what I was leading to. Also, firstly, separation. So you have the minimize the effect to what the system is instead of having it widespread. That's one. And the more you know about how things are supposed to, as Dimitri said, how things are supposed to behave, and you have domain level experts who are owning that functioning and that security, the better and quicker the response to even is a Stuxnet kind of attack. Even if you have an air gap system and you have an attack, the more—
Yeah, that's correct. That's correct, Pamela. And I would also say, though, that it's very important to protect against east-west on unauthorized east-west movement. So in Stuxnet, somebody may have stuck a thumb drive or something in a Windows machine. I'm not sure how it all happened, but that stuff had to spread laterally. And maybe those Windows machines weren't supposed to talk to each other, but were supposed to talk to some equipment. And that's what I'm talking about, is you've got to protect both north-south communications, which we talk about a lot, getting data to and from a system to the cloud or whatever. And we talk about the air gap being between north and south, but we also want to fully protect east and west lateral movement. And also I'll add that the policies, it's critical. Complexity equals not secure. So if the policies are separate, where you have to talk about this north-south policies here, east-west policies over there, you have to deal with IP addresses over here and identities of things over there, it's also not secure. And also if you have some system where it depends on learning and it's all in, some system up in the cloud that you can't see, if you can't have visibility into your policies, you can't really trust them either. So I know I just said a lot, but preventing east-west movement is also part of the deal.
I agree with that.
We're getting a lot of questions. I have no idea how we're going to answer them all, but there's a couple that came in that intrigued me. I just wanted to mention something about them. And they're kind of tied. One said, should we be focused on building in security in the edge? Wait a minute, let me get this. In the edge and gateways, this way we can provide some cover of legacy systems while introducing more secure field devices and services going forward. And there was another question that came in that said, despite the executive order, SB 327, 62443, CFAS, NIST, etc., I don't see the operators of industrial facilities asking equipment vendors for more secure products. Yet sufficient trustworthiness has to start at the sensor level. Given the lack of demand for more secure products and slow regulation, what motivation is there for equipment vendors who operate in a commercial competitive world? I wanted to mention something about that. It's basically also a call I was on pretty much right before this. I'm going to be participating at the end of July in a conference with state regulators and the financial community. These are the credit rating agencies as well as the financial types. And this is basically about the executive order. And what is very interesting is Moody's has already put out a statement that meeting the executive order is credit positive, which means if you don't meet the executive order, that's credit negative. So what we're getting now, maybe for the first time, is not so much from, if you will, the regulatory side of the world. You're getting concerns being raised by the financial types because of risk. And that has a chance, I think, to actually move us forward, because that's not going to be held up as, you've got all kinds of regulatory issues going on. This is about, and it's not really about cyber as cyber. It's about risk to the enterprise. And that's where the dollars are.
Right.
And I think that can go a long way toward trying to plug some of the holes that we've got right now. Any other thoughts?
I think that's where you hit the crux of what public-private partnerships are all about. And I think that's the direction, at least in the United States, where we're going with DHS CISA and with the ISACs, because it's become to a realization without sharing threat intelligence, without sharing best practices, and without working on certifications regulated by state and local and federal government, it's almost impossible to get a real viewpoint into the threat landscape. And so I think critical infrastructure, because it is targeted by state actors, is now becoming a priority for this type of public-private cooperation.
Yeah, and the other thing is, speaking from the financial perspective, right? That's what the organization leadership cares about, the bottom line. And I'll give you an example. There is a vulnerability that was just released called Ripper 20. I don't know if anybody's heard of that. It just came out beginning of this month. And it's so as you can imagine, it's not one, but it's a string of vulnerabilities, and some of them are of the highest criticality. The problem with that is it's in the TCP/IP stack of a particular vendor, but the implications are it's in millions of devices, including power grid, including Schneider system, including a lot of other printers, etc. The point I want to make is, because of the supply chain complexity, now for a company or for an organization to determine if they are affected by that, they need to have that kind of conversation in the beginning. They need to know who they're bringing in, what are the practices, security practices those particular vendors are following. I have actually chaired a self-certification framework for IoT development for manufacturing of those manufacturers of IoT devices. And part of the compliance, that certification framework, we have the stipulation that your vendors have to identify what kind of open source libraries they're using, what kind of production libraries they're using, etc. Okay, so it is doable. And when how it can be imposed and why it can become an important consideration is if the consumer organization realizes that it can impact their bottom line. How are they now going to determine how many devices are affected by this vulnerability? Because they will not just know that by doing a simple search. Okay, so what I'm saying is, when it hits the bottom line, that's when you get action, when you get the attention of management per se. So it's no different than a breach. It's no different than having that breach. Now you have to know what systems can be compromised, how that can be affected, etc. So that supply chain security is a very critical part of a security posture, as any good security professional already does have in place right now, if you're a CISO for organization. So I think it is tied to the bottom line, and it is tied to having that right kind of a process and posture around it.
think what we'll do now is move on to the third of the 4 questions. I'm not sure exactly how much time we have left, but I think there's been a lot of great discussion and we've got a lot of questions. And this starts with Pamela. What are the cybersecurity specific training and education issues associated with Industry 4.0, or I'll add for control systems in general?
So like I mentioned earlier, right, we are looking at an integrated whole. So when we're looking at cybersecurity talent issue and skill force, I just want to read off a statistic, okay? A CSI survey found that only 23% of the employers, and this is an IT, thought that the education programs that their employees, when they were hiring employees, were fully prepared to address the issues and what they had to manage when they were in the company. Okay. Also, ISACA. I'm not sure if anybody is familiar with ISACA, which is a global professional organization for governance and.
Can you spell it out for people or tell them what it means?
ISACA.
Yeah.
ISACA, and it's also a global organization. And they found that 61% of organizations believe that fewer than half of the applicants for open cybersecurity positions are actually qualified for the job. So we are seeing a lot of statistics that there's not enough cybersecurity skill force. But if you combine that with what we do have, may not be prepared to really handle the workload and the complexity of the systems and the complexity. Cybersecurity is a complex area. We know that. There are a lot of different domains that a lot of people don't even realize are a part of the cybersecurity domain. So if you do a CISSP certification, for instance, you know what the different areas are. If you have done a ISO 27001 certification, you know what the different areas of cybersecurity are. But keeping that aside, even with the most, I would say, in-demand skills that exist today for cybersecurity professionals, such as secure architecture, secure design, malware recognition, how to identify malware, how to, look at regex, regular expression, for instance, et cetera. System level knowledge. We are not producing the right kind of skill set. So if we look at the education systems out there, what they are, what the students are prepared with, there is a big discrepancy in what is required and what is being produced. Okay. So that's a big part of the problem. The other is IT versus OT. OT systems have a much more critical dependency on being, because they're real time, there's of the interconnectedness, and now we're talking about, IoT connectivity and 4.0. As I mentioned earlier, we haven't dealt with the old issues, and now we're introducing new ones. So their level of complexity is really high. And if you look at the statistics, Trend Micro in one of the IIoT presentations, we're talking about what the number of incidents, companies that have IoT, the number of incidents they're seeing is very high. So when we're talking about OT, we're talking about a big challenge here. Not enough resources, ones we have, may not be prepared for the workforce, and therefore are not going to be hitting the ground running. So you really cannot just take a few of us experts and solve this puzzle. We need to solve this as a systemic level, right? We need to have the right kind of security training, the right kind of practical training, which we don't have right now, does not exist. There are a couple of colleges in the country, I can tell you, because I've just applied for a grant for this, on this very topic, on creating a security training platform for CPS systems, cyber physical systems. We don't have the capability right now. So I can tell you what is required, but I can also tell you where the gaps are, Joe.
Okay. Let me, because again, I know we're running tight on time. Any other thoughts from any of the other panelists?
No, I think what Pamela mentioned about industry associations and efforts like ISACA and in general OWASP and other organizations, I think it's very important. So, and again, back to that private-public partnerships and so on. I think industry has organizations that are working on security standards and guidelines and checklists. And I would encourage all vendors and community in general to participate.
And what I'm saying is we do have certifications. SANS has certifications, for instance, for OT. That is, you are an engineer, you go for 2 weeks training, you're exposed to, we already talked about how cybersecurity is a very complex domain. 2 weeks of perhaps you're going to learn things on how to secure at the network level. That is not going to be enough for actually working in our environment and really looking at a system from a risk perspective, from looking at it holistically. So I remember I talked about Ripple 20, right? A vulnerability that exists that's going to be affecting millions of devices, including OT systems, right? If you are looking at just a network level, how to do network level security, this is not network level security, right? If it's in the software, it's in how the libraries were coded, for instance. And when you're talking about holding vendors accountable and making sure that they have the right secure coding practices, for instance, it's not going to be at a network level. It's going to be at a much more systemic level in terms of system development, application development, and of course, the risk identification of who's coming after you, how are they coming, etc. So but I'll stop there.
Yeah, I was just going to add one other point, and then we'll move on to the next question. The world of, it's the term people are using as OT, but to me it's control systems. And control systems is not just the networks, it's also the equipment and the devices. And there's not near enough training at all for how those different disciplines work together. Because one of the biggest issues in the control system world is system interactions. And there have been some really, really devastating things that have happened because of system interactions that were caused by, if you will, maybe network things that to start with didn't look to be very bad. And there, this is one of the things, when I was having some of the discussions with Pamela, that is really missing in the world of control system cybersecurity training. Let's move on to the last question. And Dimitri, that's yours. What is the impact of cloud-based architecture and web application development on the control systems, or the IoT, that's used in Industry 4.0? In other words, with the things you're doing in the IT world, how have you addressed what that means to the control systems in the control system world?
Right. Yeah, thanks, Joe. So I, as a curator of API-Security.io and CPO at Foot2Crunch, which is a REST API security company. So traditionally, I've been mostly kind of working in the space that's outside of IoT, right? Outside of traditional industrial IoT, in the space of web applications, mobile applications, etc. But with the Industry 4.0, we see that those fields are rapidly converging, and we are seeing that companies are starting to use that same stack of HTTP, REST APIs, JSON, OAuth, etc., in the IoT world, both industry IoT and consumer IoT, as Brian mentioned. And that's increasingly happening, and that has quite a few intended and unintended consequences. One is that to make Industry 4.0 really efficient, vendors are choosing multi-tenant cloud-based architectures, right? And all of these are roughly designed in the same kind of architecture that you have vendors maintaining centralized control plane in the cloud. And then you have some sort of local systems, local devices at the edge, be that industrial systems or consumer systems, like the doorbells and stuff that Brian was talking about. And then there is some control applications, be it mobile applications that consumers would use to work with their systems, or some sort of, again, industrial management applications. And they would not work directly with that other edge system. They would go through that centralized cloud, because that's obviously much easier to control, update, etc. That there are economic and technical reasons for designing it that way. But that means that your security surface actually changes dramatically, because now you have that control system that is actually not just controlling your doorbell or your centrifuge for like in Stuxnet scenario, but you have that control plane that is shared across all your peers in that system, and that means that any issue in the design of that system, in the security design, in the way that the APIs that connect those systems are designed, and in the ways that your authentication and authorization and multi-tenancy and segmentation and isolation of the tenants, any issues in that suddenly can affect everyone. And now we are getting those reports of vulnerabilities in the smart locks in apartment complexes, right? Where when one tenant can all of a sudden access smart locks on all the doors in the whole apartment complex, right? So these are the issues that we didn't have in the past, but we do now. And some of that is related, obviously, to that. A lot of that is related to that change in that the vendors and the people who are not used to work with those kind of technologies and architectures are now adopting them. And so in their industry and in their market, they traditionally cared about other things, and now they need to adopt a different stack. And unfortunately, that stack makes it very easy to iterate fast and move quickly, but not necessarily securely, right? That whole web application design technology and web application development technology, REST APIs and everything is popular for a reason. It's popular because it's very easy to get started with. It's very easy to make things quickly and make them functional but insecure. And so the silver lining here is that there is a lot. Again, we can actually, in that IoT world, we can adopt the industry standards, the security standards that have been designed in that space, right? So we can adopt things like OAuth for authentication and OpenID Connect, etc. So the technology is there, and it's a matter of learning that technology, adopting that technology, and learning from that industry, from that adjacent space. And that is often hard, right? So we can see, for example, that in that whole 5G security is now a very trendy field, but unfortunately, most of the discussion that we hear about in the 5G security is whether Huawei hardware equipment is safe or not safe, controlled by foreign government, not controlled by foreign government. But apart from a few security people in some of the telecom vendors, we do not hear much talk about 5G actually now going fully transformed to use that commodity technology stack. 5G is all based on HTTP, REST APIs, OAuth, and so on. And that's a huge transition. And that includes all the service-based architecture in all of 5G. Has nothing to do with hardware, has everything to do with API security, REST APIs, and defined inputs and outputs, and allow lists that we've been talking about, et cetera, et cetera. So I think there's a huge impact of that and huge convergence that we need to take into account.
Any other questions or comments from the panel? It's getting to be closing time. So what I was going to do now is ask each of you from the panel to sum up your thoughts from what you've heard or what you want to get across. Let's work backwards. Dimitri, I'll start with you.
Sounds good. Thanks, Joe. So like I mentioned, I think we're living in a very exciting times of IoT, industrial IoT and consumer IoT. It's racing rapidly, rapidly changing, rapidly enabling us to do a lot of things, right? So a lot of technology is now becoming widely accessible, technology that would have been part of science fiction 10 years ago and sometimes even 5 years ago. However, that also means that security is becoming a big part of it, and those systems are no longer no longer isolated, and on the other hand, they are no longer toys. These are things that affect our day-to-day lives and our physical security, and so security can no longer be taken for granted. So I think it's great that we had that discussion, and I think that the things that everyone on the panel have been iterating and reiterating today are very important. So security being there by design, security having to span all the aspects, spanning networks, spanning applications, control planes, etc., and just being there properly designed and properly enforced.
Pamela?
Yes, sure. So I would just say, again, reiterate that when we look at security, we cannot look at it in silos. We've got to look across the organization, how systems are laid out, how they can be, have the right processes in place. And when it comes to things such as, just OT, even ICS security, for instance, we have to have, there are so many different ways of creating a secure environment, which will make sense depending on what infrastructure there is, what kind of a organization it is. So it's going to be very contextual. However, there are best practices for onboarding, for instance, for identifying, authenticating devices, what is allowed in your network. These are well and proven approaches that can work for anyone. Now, when it comes to what you can do wrong also, the implications are extremely high because, we didn't talk about Shodan, for instance, using Shodan for finding ICS systems that are on the internet. It's readily available. It's, attackers can leverage, very easy to use tools such as Shodan to find what building system, information management systems are connected to the internet, for instance, or to our energy SCADA systems are attached to the internet and with what credentials. So that aspect being one thing, then there's also the, knowing your environment, making sure that you know what's in the environment, where the security falling out could be, such as the, Ripper 20 I mentioned. And also then following, like I mentioned, you have to take a look at it holistically. So attackers are out there. There's the MITRE attack, which is a great free tool for anyone to use. and identify what are the tactics attackers use, and how are the different ways that they, it's directly related to threat intelligence. These are things that already exist out there, and they're free. So just, you have to know what your risks are and find out what you can do about it holistically, though.
Brian?
Yeah, I'm going to try to make this real quick. So I think just main points. We need to make the infrastructure that we have right now good for Industry 4.0. That's one thing. More networks, more complexity equals not security. Let domain experts connect their things in an inherently secure, encrypted, and mobile-friendly manner so that they don't need to use patch cables and work around the system. I think control systems can coexist with IT and other networks, get all the benefits of big central data processing by using zero trust positive security model. And we need to build a logical air gap for the network of things. Thank you for letting me be here and for participating today.
Thanks. Chuck?
Sure. I just basically took notes on some of what my colleagues were saying, which is very informative. And to summarize things, it really just still comes down to cybersecurity. It comes down to processes, technology, and people, and risk management. And so the elements that I took away from Dimitri and Pamela and Brian were, security by design. You got to build agile systems with operational cyber fusion to be able to monitor and recognize and respond to threats. You have to have visibility to be instilled up front in the process where you map your control systems and your communication flows. You need to have access management and encryption of data flows, and segment or air gap as much as you can of OT and IT. And you've got to look now forward to, because of the training issue, the lack of qualified people, and the diversity of the verticals too in industrial IoT. You have to be able to rely more on automation and some more emerging technologies such as machine learning and artificial intelligence to leverage security into the system. And thank you again for having me too.
Well, number one, I wanted to thank the panel. This has been really fascinating for me because it's a really interesting, diverse set of people. Just wanted to point out one thing, and then we'll do the final thank yous. Pamela had brought up Shodan. And the reason that struck a chord, we keep talking about IoT or IIoT. And one of the biggest questions of all is, what is I? In other words, is I www. Is that the internet? Or is that a local? Because one of the things that we keep saying is you should never be connecting control systems directly to the internet. So kind of an interesting point of what is it that we're really talking about when we talk about that I of IoT or IIoT. Like I say, we didn't have a chance to go through all of the questions. There were like 12 or 13 questions. I think Lucian has got them all, and we'll figure out how we respond from there. I wanted to thank Lucian and IIoT World, the panelists, and our two sponsors, Trend Micro and Tempered Networks. And hope everybody found this worthwhile and of interest. Lucian, you want to close it up?
Yeah, thank you everybody for joining. I certainly learned a lot. I'm sitting here listening to all the experts, and I'm thinking, I got a lot of young students that want to choose a path. So they've been asking cybersecurity. There's a lot of gaps. You talk about training. There's 2 million people gaps in the cybersecurity alone. Industry probably was a small version of that, but sounds like there's options out there to take a path. So I really appreciate all of you dedicating the time. There's over 95 speakers. You folks have made this. Without industrial IoT wouldn't be possible, or connected in the industry wouldn't be possible without having a foundation in the cybersecurity. So I appreciate everybody's insights here. And with that, I think this concludes the program for today. So have a good rest of the week. and appreciate the support for IoT World Days.